Hi, I'll be talking about Internet of Things, but before I proceed, I'd like to acknowledge Mr. Hadi Nograles for letting me use his learning materials, especially this one, this particular slide that I'm going to use for this video. To proceed, what is Internet of Things? The Internet of Things, or IoT, is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers or UIDs and the ability to transfer data over a network without requiring human to human or human to computer interaction. A thing in the Internet of Things can be a person with a heart monitor implant, a farm animal with a biochip transponder, an automobile that has built-in sensors to alert the drivers when the pressure is low, or any other natural or man-made object that can be assigned an Internet protocol or IP address and is able to transfer data over a network. Increasingly, organizations in a variety of industries are using IoT to operate more efficiently, better understand customers to deliver enhanced customer service, improved decision making, and increase the value of the business. So, these are the different components of IoT, which I'm going to discuss in details in the next succeeding slides. So, the first one is the sensor. The sensors or the devices. Sensors or devices help in collecting data from the surrounding environment. A device can have multiple sensors, so pick and collect from the surrounding environment. Basically, these are could be infrared, it could be a weight sensor, or it could be a heat sensor. These are the sensors, so these are the devices of your IoT. Next is the connectivity. Connectivity, that connected data is sent to a cloud infrastructure, but it needs a medium for transport. So the medium can be the air, it could be the fiber optics, or it could be your copper wire. So cellular networks, satellite networks, Wi-Fi, Bluetooth, wide area networks, or WAN, low-powered wide area networks. These are your examples of connectivity. Some specification and trade-offs between power consumptions, range, and bandwidth. So depending on the connectivity that you're going to use, so there will be trade-offs. Next is number 3, which is the data processing. You will be sending data, or not necessarily you, but your IoT device or application will be sending data from the device itself and to the processing server. So there should be data processing there. So data is collected and it gets to the cloud. Normally it goes to the cloud. The software performs processing on the acquired data. In some situations, a user is required to interact upon data processing. Example, if the temperature is too high, what will the user do? Should the user turn off a certain switch so that the temperature will drop, or uh, press a certain switch so that there will be a cooling system that will be turned on? So those kind of things. And then the fourth one is the user interface. The information made available to the end user in some way. So there should be a user interface for your IoT. So it could be the input or output device, or it could be your display, so that you will see what is happening to your to your to your device. So it could be a simple display like an LED, or it could be a more complex display, which is a it's just a screen. And then example is triggering alarms on their phones or notification through text or email. So that's a example of a user interface. So the user can actively check the IoT system, and then the user can also be able to perform tasks and control or have a feedback to the IO system. In some cases, some actions in the IoT system is performed automatically. And this is the different type of IoT. So it shows here the speed and the range. So you have Wi-Fi, Bluetooth, cellular, 5G, 4G, LTE, etc. And then you have LP1, you have LP1 license and unlicensed LP1, and you also have RFID there, the lowest in terms of ranges, in terms of power consumption and range. So so what? So now we will talk of those types in detail. So we'll start with the L LPWAN or LPWA, which stands for Low Power Wide Area Network, or Low Power Network (LPN). It's a type of wireless communication wide area network designed to allow long range communications at a low bit rate among things, such as sensors operated on battery. So it's long range. The operation range of LPWA and technology varies from a few kilometers in urban areas to over 10 kilometer in rural settings. It can also enable effective data communications in previous invisible indoor and underground locations. So there. It's low power, optimized for power consumption. LPWAN transceivers can run on small and expensive batteries for up to 20 years. And it's low cost. It's simplified lightweight protocols, reduce complexity in hardware design, and lower device costs. Its long range combined with the star topology reduce expensive infrastructure requirements, and the use of license-free or license band reduce network cost. Next is the cellular Internet of Things, sometimes referred to as mobile IoT. Are IoT devices connected to the internet via cellular networks. So manufactured with a SIM slot or eSIM. So specifically for your IoT, not the one that you will use for calls, for text, or even for data. So the coverage, cellular networks are ubiquitous. It means that they're already there, especially in high density populated area. So you can always have a cellular signal. So it's mature and it's reliable, at least in most areas. And then it has global reach. There is no other network technology with the reach of cellular technology. And then the security, SIM-based authentication and utilization of VPN tunnels make cellular the most secured options. The installation works out of the box without requiring local installation or technical expertise. All you have to do is just uh, uh, go get your device and then insert the SIMs and you're good to go. You can already have a signal from your uh, cellular tower. Then it's low or no power. Cellular modules can consume 8 milliampere of power, and networks are still available in the case of a power outage. Next is Zigbee. So Zigbee is a short-range, low-power wireless standard IEEE 802.15.4, commonly deployed in mesh technology topology to extend coverage by relaying sensor data over multiple sensor nodes. Compared to LP1, Zigbee provides higher data rates, but at the same time much less power efficiency due to mesh configuration. So that's Zigbee for you. So it's flexible network structure because you can just expand it however you want. You can just add more Zigbee. Low power consumption, and then easy installation and implementation. Large number of nodes. You can go up to 6,500 nodes, more or less. Very low cost, more reliable and self-healing. Low transmission rate. This is one of the cons, and not secured as compared to other technologies in the list. And does not have many end devices because it's something that you still have to program and customize. Next is Bluetooth. So for Bluetooth, this is also relatively matured technology. So advantages is low power consumption, low bandwidth, prolification in smartphones, relatively simple development process, no fees to access the core spec, low development and module cost, no outrageous licensing cost. You can just use Bluetooth without worrying about licenses. Disadvantages: low bandwidth, so you can only transfer data, a relatively small amount of data to and from your device to your processing center or your processing server. Limited range, typically 30 to 100 meter, but steadily increasing with each iteration of the spec. So as of now, it's 100 meters. We can expect it to increase to probably uh, another 100, but I'm not sure if it could go thousand of kilometers or even meters. Requires a gateway device to connect the end devices to the internet. So it's not a standalone. You still have uh, to be able to connect to the internet. You have to have a gateway device. Interference and noise from other protocols in the 2.4 gigahertz spectrum, since it's the frequency is 2.4, around that. So there's a tendency to interfere with other devices on that range. Can be difficult to debug. Issues with communication, especially relating to longer ranges and interference. So there are advantages, and of course there are disadvantages. So normally you will use Bluetooth for simple applications and not critical critical applications. And then of course you have the Wi-Fi and RFID, and I'm not going to really discuss them uh, in details. I'm going to probably ask you to do some activities on this one. Choosing the IoT platform. So one of the things that you have to consider is the scalability. So when you choose a platform, is the platform uh, scalable? Of course, if you're going to use Bluetooth, you'll be limited to a certain degree. But if your application, you're thinking of application that would add more components or more modules in the long run, then you have to use or choose a platform that would allow you to grow. Next is power consumption. Is your application, IO application, power hungry? So you also have to choose the particular platform that will give you that kind of that kind of power requirements based on your needs. Then mobility. Is your application something that's highly mobile? And how how would you want your application be secured? Is it okay to compromise a bit of security? Is your application involving personal information? So, and then standard used. Do you subscribe to a particular standard that you cannot use any other application but only a certain application, or only a certain platform for your application? Then network management. Do you require easy management for the network, or you don't really mind managing the network as long as you get your data and you're able to send and receive data? And then bandwidth requirements. Is your application or your IoT application, it could be a program or it could be a device or a system, needs a lot of bandwidth? Do you transfer large amount of data between and from your application to your server? And then the range. Do you require it to be long range? Do you place your different application in different places? How far will they be each from each other? How far will your application be from your server? And those considerations. And then the quality of service. Is it okay for you if there will be some drops in packets, or if there are no signals, or do you require a permanent connection between your device and your server, or between the different devices that you are deploying? And then the market longevity. Do you require a certain, or are you coming up with a certain application that would be there for the next 50 years? Or will it be something that will just be used now, and you're thinking probably in 5 year times your application will no longer be needed? So you also have to think of those things. So these are some of the things that you have to consider when you choose your IO platform. So you could use your uh, Bluetooth, you can use the Wi-Fi, or you can use the wide area network, the one Zigbee, or you can use the cellular technology. And here are some of the applications. So you have there some application listed here. Key IoT vertical, so industrial IoT. So industrial IoT would most likely use WP1. It could also use cellular technology or Zigbee. And then you have smart meter. Normally you use LP1 smart meter. Probably this application are for reading some water consumption or power consumptions. So you will be needing their LPW1. And then smart city. So smart city is the LPW1. Uh, Smart building also is LPW1. Smart home could be Zigbee or simple star and mesh. It could also be Wi-Fi for your smartphone, for smart home. Wearables can be LP1, but most likely it's a star or a mesh. Uh, Connected car, it could be Wi-Fi, but this is still under experimentations, and that particular technology is not yet a mature one. Then you have connected health, so it could be cellular or it could be BLE. And logistic, assets asset tracking, RFID, it could be RFID if it's on site. and then cellular also LP1. So most likely it would use cellular or RFID. And then smart agriculture, so it's LP1. So these are just some of the application and their corresponding IoT technologies. So with that, I'm going to end the lecture. So expect some requirements, some things that I'm going to ask from you. So thank you very much for listening. I'm going to end now.